Okay, we've got a fairly straightforward binomial expansion question. It's simple because we've got a positive integer power of 7 here, which means we can use the simpler form of the binomial expansion formula. But I'll show you them both and we'll have a go at this one, okay? Okay, as promised, here are both the binomial formulas. The bottom one is the one most usually quoted. The top one, its restriction is that n must be a positive integer for it to work. And as most of the time we use this bottom formula, what I'm going to do is I'm going to work this question out using the top formula, because we do have n as a positive integer, and a and b can be substituted for any value, whereas in this formula we would have to get rid of this 2 and turn it into a 1 to use the bottom formula, because it is quoted as 1 plus the x component. From the question we're given, a is equal to 2 and b is equal to x divided by 2. I should put the negative there as well. Okay, let's go through. They need the first 3 terms, so all this lot we can ignore. Okay, let's do it. So we've got 2 minus x over 2 raised to the power of n, and that's equal to a to the n, which is 2 to the power 7, plus n, which is 7, multiplied by 2 to the power 6, multiplied by b, which is negative x over 2. So that's our first 2 terms, plus 7, 6, divided by 2 factorial. Don't start multiplying 7 multiplied by 6 in your head. It's much better to leave these all as separate integers and then cancel. So that's done the first bit. A now again, so this is 2 raised to the power 5. You can see the pattern, 2 to the 7, 2 to the 6, 2 to the 5. And then b, this is going to be negative x over 2 raised to the power of 2. And it's usual to add that to indicate that you know that the series does go on. So before we calculate values of all of our terms, it's wise to do some cancelling. This 2 will cancel with the 6 up here to make it 2 to the 5. This is 2 squared on the bottom. So that 2 squared will cancel with the 5 to turn it into 3, but we've got another 2 down here. So both of these 2's, we've got 2 of them here and another 2 there, so that's 2 times 2 times 2, will knock that 5 down to a 2 squared. So now we can start multiplying out. This is going to be 128, 2 to the power 7 is 128. Let's have a look at the sign of this term. With the negative x here, this is going to be negative. 7 times 2 to the 5. 2 to the 5 is 32. 7 times 2 to the 5 is 224. We've got rid of the underneath, so this is just 224x. Now, is this term positive or negative? Well, this is going to be squared, so this will turn positive, and we've got a positive here, plus. So once you've got a pattern generated in the first couple of terms, that pattern will repeat. So this is going to be x squared. And all we've got to do is work out the coefficient of what we've got left. This is 4 times 7 times 6. And that turns out to be 168. And this goes on. And that will be the answer to part A. Part B. Now we don't have to do any calculation of 1.995 raised to the power 7, but we've got to explain how we would do it using our expansion here. Well, if we want to calculate 1.995 raised to the power 7, this is our expression for 1.995. So if I set up that 2 minus x over 2 is equal to 1.995, so all I've got to do is solve for x in this equation, and then that result goes into our binomial expansion, and we can get an estimate for 1.995 raised to the power 7 just using our binomial expansion. Okay, solving this, I'm going to multiply through by 2 all the way through. So I get, therefore, 4 minus x is equal to 2 times 1.995. And that turns out to be 3.99. And therefore, moving things round, x is equal to 4 minus 3.99, which is equal to 0.01. And what that means is if I substitute x is equal to 0.01 into this expression, we will get an estimate of the value of 1.995 to the 7. And that's the answer they were looking for.